Good evening. I am broadcasting tonight from the University of Utah. I just wanted to show you this. Okay, I'm really not going from University of Utah. But anyways, that's the greatest college in the nation there. I just wanted to remind you, you already knew that, but just in case you forgot. Jake, come here. Come here real quick. Show him your cool mask. You going to show him in the camera? He is our transformer. That's why he's always beating up his sisters. And here's our other kids. Christopher is acting like a dog, but he's naked, so we're not going to put him in the picture. And there's Aubrey. Okay, y'all go on. You should see the look that their mom is giving them. Okay, love you.
She's like...
Keep going. Uh-oh, you better hurry. She's counting. She's counting. Hurry, go, go, go. All right. Anyways, so today my wife is my production manager. She actually made a really good recommendation. She said, why don't you write in a different color from the problem? So that's what I'm going to do. So we're going to start off, we're just going to use the step method on this first one. So here is here's our equation today. We're going to start off with silicone and oxygen plus hydrogen and fluorine. We're going to create silicone and fluorine and water. So let's start off with our silicone. We've got one molecule of silicone on our reactant side. We go to our product side. We also only have one molecule of silicone. Those are balanced. Let's go to oxygen. Two molecules of oxygen on our reactant side. So we go to our product side. We've only got one molecule of oxygen on our product side. So what do we multiply that one molecule of oxygen by to get 2? My wife wins. So 2, that's right. So we multiply it by 2. Alright, so then that 2 is going to multiply the hydrogen and also the oxygen. So then we go to our next molecule, hydrogen. We've got one hydrogen molecule on our reactant side. We go on to our product side. We've got 4 molecules of hydrogen. So what do we multiply our one hydrogen by to get 4? We multiply it by 4. So now we've got 4 hydrogen. So then we look at our fluorine. Now remember, this 4 is going to multiply both the H and the F. So now we have 4 molecules of fluorine on our reactant side. We go to our product side. We have 4 molecules of fluorine. Now we could say that this is balanced, but just to be safe, we're going to double check everything. That's the step 2, is double checking. Silicone, 1 on the reactant. We've got 1 on the product. Those are balanced. Oxygen, we have 2 oxygen on the reactant side. We've got 2 oxygen on the product side. Those are balanced. Hydrogen, we've got 4 hydrogen on the reactant side. We've got 4 hydrogen on the product side. Those are balanced. Then fluorine, we got 4 fluorine on the reactant side, and we've got 4 fluorine on the product side. So everything's balanced. So we are done with this problem. So let's move on to another one. And this time we are going to use the odd method, where we focus in on the odd number of molecules. And hopefully by focusing on the odd number of molecules, we'll be able to come up with a solution here. So let's see, let's do blank P4, O10. P is potassium, O is oxygen. That's combined with water, H2O. And that is going to create H3PO4. Okay. So let's take a look. Let's start with our odd number of molecules here. So I'm going to look at my oxygen. I've got 1 oxygen on my reactant side, but I go to my product side and I've got...
I have 11 oxygen.
My wife just corrected me. See, this is what happens if you try to go too fast. You look over oxygen. So we've got a total of 11 oxygen, but here is an odd oxygen right here. So I'm going to just try to make that oxygen even. That's all I want to do right now, is just make it even. Why? Just because it's part of the method. So I'm just going to multiply by 2, and that's going to give me an even number of oxygen. Now I might have to come back and change that number, but right now it's even. And the reason why it's important that it's even is because if we look on our other side, on our product side, we've got 4 oxygen molecules. We can never make that an odd number. We multiply by 1, 2, 3, 4, it doesn't matter. Our oxygen will always be an even number of molecules. So they're all even. There's no other odd ones until we go to the hydrogen. Now the hydrogen, you're going to notice there's 3 molecules of hydrogen. Let's just make it even. It's an odd method. So we're just going to try to make it even. So we're going to multiply that hydrogen by 2. So now we have 6 hydrogen. So now the hydrogen are even. Okay, now let's go through and start balancing everything. Now we know that we have to keep this even to make this even. We have to keep this as an even number to keep this oxygen even. That's important. We've got to keep those 2 numbers even. By having 2's up there, that will help remind us that they have to remain even numbers. So let's go to our P. P's for potassium. We've got 4 potassium on our reactant side. We go to our product side, and we've only got 2 because we multiplied that 2 over there. Well, in order to make it 4, I can multiply it by 4. So I can erase it and multiply by 4, and now I've got 4 potassium on my product side. So then let's go to our oxygen. We've got a total of 12 oxygen right now on our sides combined together. Well, if we look at the product side, we've got 16. So I've got 10 right here, I've got 2 right here. Now, I'm going to work with the smallest number. This one right here is going to be the easiest one to change. So I'm going to erase that 2. Now I've got 10, and I need a total of 16. So what I multiply this 1 by, that I can add to 10 to get 16. I can multiply it by 6. Because that will give me 10 right here, and that will give me 6 over here for a total of 16 oxygen. And I have 16 oxygen on my product side. So now I've got, and notice that stayed even. So now my oxygen are balanced. So then I need to look at my hydrogen. So I look at my hydrogen, I've got 12 hydrogen on my reactant side, and I've got 12 hydrogen on my product side. We could say it's balanced, but always, always, always double check your answers. Potassium, 4 on my reactant side, potassium, 4 on my product side. Oxygen, got 10 plus 6, so 16 on my reactant side. 4 times 4 gives me 16 on my product side. So then I look at hydrogen. 12 hydrogen on my reactant side, and then on my product side, 4 times 3 gives me 12 hydrogen on my product side. So this is balanced. And that odd method, it is an odd method, but it's, you know, you can try it. You can try it. All right, well, let's do another one. This one, my favorite method, to be honest with you, is the step method, so I'm just going to go with the step method on this last one as well. So let's see, we're going to do SB. I'm not sure what SB stands for. Renee, do you know what SB is? So whatever SB is, we can look it up. Who knows, right? I bet Mr. Lockhart knows. So then we go, so we get SB 406. Now, O, we know what it is. O is oxygen. This one looks pretty easy. Before you continue watching this video, push pause and see if you can solve this on your own without watching the video. Okay, welcome back. It's nice to have you back. I'm glad you pushed pause. So let's take a look at our SB, whatever that is. So right now I've got 1 SB on my reactant side. I look over on my product side. I've got 4 SB on my product side. So what do I multiply this single SB by to get 4? My wife went 4. You should see her. We should turn the camera around. So we've got 4 SB on our reactant side now. We've got 4 SB on our product side. Now let's take a look at our oxygen. We've got 2 oxygen on our reactant side. We've got 6 oxygen on our product side. What do we multiply that 3 by to get 6? I'm sorry, that 2 by to get 6. I just gave away the answer. You multiply it by 3. So now we've got 6 oxygen. We could say it's balanced, but just check. I know it seems so simple, but let's check. 4 SB on our reactant side, 4 SB on our product side, 6 oxygen on our reactant side, 6 oxygen on our product side. This is balanced. That's it for today. Yeah, good luck. We'll see y'all later.